Okay, yeah, sound is good. Let's just check again. Okay, one little problem again, as always. Okay, not now. Who? Okay. Okay. Now let's just see what another problem I have. Okay. Right now, if I started, well, the desktop sound is for some reason doesn't is not working. Forgot. Stop right there. Where are these things? Okay, well, I'm telling too much, okay, but anyways, desktop sound is not working, seems, at least. Oh, it's working. What do I have to do is just switch this thing to somewhere. Well, it simply doesn't work. Little things which don't really work well. Whatever. Okay, so in this stream, I will be just creating some strategy game similar to Banished, and that is I'm I'm not sure if you have played it or not, but it's I really like that game, and yeah, but I just decided for this stream to to create something like that and extend its features a little bit more in the coming streams. So it using maybe someone's ideas from my friends, what should I add and so on, to make a game very similar to Banished but with more features. And yeah, that's pretty much it. And we should begin doing so. And to do so, we would we would probably have to begin from the terrain generation. And yeah, that is it. So we just create a new folder, scripts, and create a new folder called uh, terrain. And my idea is actually to not generate like pre-generate the terrain and you have a limited size map, but instead have an infinite map with some random villages generating that you could just tell your people to take over and you just expand infinitely unlike in Banished. So that is my idea, and to do so we have to create two scripts, not one. The first script would be chunk, chunk, a single chunk, and the second script would be a chunk controller. And yeah, and we just open up this thing. I'm pretty sure it won't open up correctly. And let me just quickly find it. Where is it? Okay, it didn't work yet. Oh, I have to go ahead. Scripts, terrain. Oh, I have to file open. Well, all files. Okay, so just chunk, open this up, we can close this. Little problems, monodevelop doesn't work yet. Fine. Well, still doesn't work. Okay, let me just open up another thing. Chunk controller. Okay, so we have these scripts right there. Let me just go ahead somewhere. Click on this thing. Okay. And in this script we have to set up some variables. The first one would be, of course, seed, world seed, and it is integer and something like that. It's a default seed. For now we will just stick to this seed and that's it. Another is chunk sizes. One moment, I forgot to get some water ready. Okay, I'm back. Forgot to get some water ready for the stream. And now, other variables are for chunk size, but right now, well, these will not be relevant. And that's it, actually. Well, we don't really need this, I'm pretty sure. Let me think about it. No, I'm thinking we don't need that. We need a variable called chunk number, which would identify which chunk it is. Vector 2 equals vector 2 0 0. Okay. Well, we probably need that. Yeah, we need that. These variables other var chunk size, and it is a vector 3, which is equal to 16 1 to 8 16. Well, for some reason it tells the audio bitrate is 96 kilobits, which we definitely have to check. Output audio bitrate is 320. You're lying to me. Why you lie to me, YouTube? Anyways, so we created this variable for the size of chunk, and now we have to do something like mesh, which will be just mesh, and it will be mesh array, but yeah, new mesh 1, And now there are other things we have to keep in mind, uh, which would be var new vertices list, which would be list vector free list array. Yep. Now the same goes to triangles. Triangles would be, well, let's see, it would be, as I said before, list of integers. List of integers array. Yep. And then materials. Materials, it's an array. Okay. So now what you have to do is do something with generation. We will use Perlin noise for generation, and that is all about it. And we have to set up some variables. In the top, first of all, you have to type in random seed boolean equals false. And right now, as we use Perlin noise, we have to do some noise intensity pass just float equals 1, and we will have 3 passes, which is pretty simple. 1, 2, 3, and it will be right there 0.5, and right there 0.2. Sorry. Now the same thing will be noise scale pass float, and this time is 0.1. Okay, like so. Oops. Pass 1, 2, and 3. 0, 2, 0, 5. I think that should be good. We will see when we write the actual code. We will be able to edit this stuff. And to make it cleaner a little bit, like so. Now what do we do? Wait one moment. We create in start function, we just call a function which we'll write later, generate chunk, because we don't really want to write in start function. And yeah, function generate chunk, and yeah, we do if random seed, then seed is equal to mathf dot round to int random dot range minus 100,000, so it will be 100,000. So it will be 200,000 seeds available in the game. So 200,000 different worlds. And yeah, that's it for the seed. So now we do the actual generation. MF, which stands for mesh filter, get component mesh filter. I'm pretty sure it will work. And the scene goes to var vert vector free array. I'm pretty sure I'm quite sure we don't really need these. I'm not really sure about that. Will we need that? Yep, no, we don't need that. Which would write this one would be, well, it would be equal to mf.mesh.vertices, and we will use the basic plane, which is, well, we will modify the plane, so we don't really need to generate the meshes ourselves. Well, that's not very hard, but still we won't need to do that. So for var y int equals 0, y is less than verts dot length, forgot to change this to this, y plus plus, probably, yeah. Okay, so our world position is vector free, and that is equal to game object dot transform point vertices y. So this will make the actual terrain be generated correctly, because because the point of the vertice will be known. Where is it exactly? And now what do we have to do is verts dot y is equal to Perlin, which would be world position dot x, world position dot z, noise intensity pass 1, noise scale pass 1. I'm Pretty sure that that's what we are looking for. And we will do very similar with all of these. Plus, plus. Except it's pass 2, pass 3. And now we write the Perlin noise algorithm to clarify what we call Perlin x float z float noise intensity float noise scale float, as well as that's it, I think. And now what it does generate the noise. Or it just make sure it returns float. It's very important. And it does return math av.perlin noise, which is x plus our seed divided by chunk size dot x multiplied by noise scale then we do z plus seed, very similar, divided by chunk size dot z and multiplied by noise scale. And now this whole thing gets multiplied by chunk size dot y divided by 10 multiplied by noise intensity. Well, maybe 10 is not much needed, but still, yeah. Well, maybe we don't. Noise intensity goes like so, 1 point. Yeah. Let us just see what we did. How many errors. Oops, console. Float 46. Function Perlin. Oh, it's not float. Oh, flow. Oh. Okay. Yeah, vertices. Okay. Now we didn't actually finish the world generation. To do so, just vertices go vert mf.mesh dot recalculate bounds recalculate normals and then get well, maybe we don't need it yet, but we still write it. Get component mesh collider dot shared mesh. It is equal to mf dot mesh. "48. Verts and let's just create a new 3D object, plane, move it to 0, 0, 0, and attach the component, which would be chunk, and it has everything we need. Well, that's not what we expected actually. Well, this looks quite weird. Really weird. And if we multiply it by 10, let's see what we have. We have even scarier thing actually. Yeah. That's why we need this 10. Okay. That is what it is. It's quite weird. It is quite weird actually. I'm not sure why, but it is. Okay. Okay, let's just see what we have. Wait one moment. Okay, well, let me just go ahead and see what did we do wrong, because we definitely did something wrong. This probably is all right. Well, let's see. If we do just like so, what do we get? Something weird, as always. Let's just see. What's the problem? What's the problem? Okay. It's pretty stupid. We have a problem with really weird generation, which is quite weird, as I said before. If we do it like so, and what if we just don't use the y multiplier thing? Okay. If we do noise scale, something like 10. Oh, we didn't save the scene yet. Game. Oh, here we go. We're actually getting the world generated like so. But what do we have to do right now is we need to use one. Okay, so it's 0.5 and 0.2. And if we go multiply this chunk size.y and divide it by 10 and multiply by noise intensity, we should get something. We got a hill, and yeah, and I'm pretty sure if we move it like so, we got a hill. The problem is with these vertices, for some reason they just stay on that position. We can try one thing, which would be in invoke repeating generate chunk, which would be 0.5. Let's just see how it works. You will be able to see that the problem is with something still. As you can see, if we go ahead and do this in update, generate chunk, you should see that, well, the terrain gets somewhat glitched in this point, which is not what we want, because, well, for some reason these vertices do not get set. Oh, really? We made a mistake like this, which is pretty terrible. And right now we have everything fixed. Really, what a mistake. But well, it's kind of cool to see it like so, and if we scale it, it gets scaled properly. Let's say if we go 10 by 10, it still gets scaled properly. It's very interesting. But well, the quality is lower on this mesh. Yeah, we generated a mesh, but we still need to do something with it. Set it to 0. We have generated it. It's very cool, you know. We first of all maybe want to set the scale of it like so to make the mesh quality, well, lower, because, well, we won't need that big quality, and we just, if we set it to 5, let's just see. Oh, so probably we need to use 0.2, and yeah, let's just see. We just use 1, yeah, because it sets the vertices, and we have to enable back these other passes. And now it is just alright. But now we have to do another thing. we will have only one biome in the game, but and not but, and we want lakes and hills, and we want to have some pretty flat area. And the flat area will just have the let's just see how it all actually goes on. If it's all on 0, 0, 0, 3D object cube, we have it like so. Which at which part should our lake be going? Okay, so the lowest part is somewhat something like 6. I want our lake to be going somewhere around this, maybe this 8 will be the point when the lake will when it will be ground. Everything between, let's say, 7.5 and 9 will be at the same height. So just let's do it. And that is var max min flat float, which is equal 7.5, as well as max flat, which is float of equal to 9. And yeah, that is it. And it does like so. Well, let's just think about it. And the flat value will be 8. I'm pretty sure. Var flat value is equal to 8. And it's float, of course. And yeah, we have this, and we have just, first of all, maybe let's do it without these passes. And if, let's do a bit pretty hackish way actually, if verts y is more than min flat, and verts dot y, and it is y like so, not this is bad. This is bad, guys. Don't try this at home. Yeah, it's like so. Y, again, is less than max flat, then vert y dot y is equals to flat value. Let's just do something. Okay. let debug dot log works. Let's just say that works. There are quite many. Move this up. Well, maybe let's see just if from 1 to 15, let's just see how flat it gets. It simply doesn't get flat at all. Whereas y to t flat value, it's 8. Whereas y equals flat value. Plus, maybe plus, words y dot y. It goes like that. Oh, I understood. What did I do wrong? To make it pretty flat, I have to do like so. As you can see, we got a lake. Right like so. Which would be like so, and the flat value like so. 4, this will be 9, 8 maybe, min flat is 3, whoa, hills, 6, yeah, it's pretty much like so, I'm pretty sure. Now what do we have to do is just enable these. What did I just do? I don't need this. Now if we enable these, we just made the world higher. Okay, make sure we copy these. Paste component as paste component values. Maybe just 2 and 2 maybe. And we have it. Okay, let's just see. 0.05. This 0.2, but scale has to be like so. Nope. 0.5. It has to be 0.2. Intensity maybe 2 and 3. Oh my god. Nope. Okay, let's just right now what do we have to do is we don't need that, or we don't need this. Yeah, we better don't need this. And right now if we move around we have a perfectly nice world with hills, completely adjustable. So if we want like steeper hills like this, and if we want less lakes, smaller lakes, a little bit flatter world, this is nice. As you can see, we have lakes which we can just expand like so. Which gets, we can make pretty weird results out of this, which is, well, can you have, yeah, pretty weird results. You can have, let's see, just set on 3 or 1 or 3.5. So yeah, you get a lake, you get another thing which is like so, or 6 maybe, like so. Noise scale, does it make it like so? Nope. And yeah, this is actually pretty much it with this lake world generation thing, which is, well, what you can see, a lake world generation thing. Okay, another thing would be, let's just see again, would be the next thing would be actually something like building structures. Before that, why don't we just make this thing grass and something like that? Okay, create the object plane, which would be pretty big. Let's just see. In lake, well, let's just see how does this thing affect this? A lot, really a lot. And we just go ahead, put this at 4 is bad. 3.9. 3.8 probably, and we just copy this, paste component values, make the scale like super big, and we just go ahead, create a new folder called materials, and this will be water. And in materials folder we create a new material called water. We just go ahead, water. And now let me just find where that thing is. It's in my other uh, project. Okay, let me just find it. Documents, where is that thing? Yeah, found it. Assets, and it should be in textures folder probably. Other, well, let me just check it out. Water. Okay. Nope, it's not that thing. Okay, maybe this. Assets, let me just find it. Well, it takes quite a long time. Whoa. Environment, probably water. Water. Textures. Water basic, okay. Let me just go ahead. Open containing folder. Textures. Bump map thing. Which would be bump map. Normal map. Which would have this set as normal map. And it's something blue. course it goes like this. This on the other hand has to be like so. 100 on 100. Okay, and yeah, we have it, the terrain generated, which has a lake thing stuff. And yeah, that's about it for this terrain. Now other thing which has to happen is probably with the controller. In main camera we go ahead and create chunk controller. And that is a different story actually. And we don't need this. Close. Open. Unity projects. Maybe right there. Okay, here we go. Chunk controller, here we go. What do we do now is go ahead and let me think a little bit. Let me think. Okay, we have to go ahead and create some variables, of course. And what it does, it has an array of things, loaded chunks, which would be an array of chunks, maybe like so. The range, the distance of array, the distance that would generate chunks actually, is integer which is equal to 8. And now we have other things. Chunk size, vector free, which is actually as if we count the stuff, how many rectangles we have, you will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have to use 10. 1, 2, 8, 10. Yep, that is right.